What does it take to eradicate recurrent Clostridium difficile infection? The role of the microbiome. Microbes are the dominant form of life on the planet in water and soil ecosystems. Humans are no exception. More microbial cells exist in the body than human cells, including the trillions of microbial cells that inhabit the gastrointestinal microbiome. These microbes are not simple bystanders in the body, but provide key functions essential for human health. In this symbiotic relationship, the host provides nutrients, and in return, the microbiome supports metabolism of non-digestible dietary fibers, synthesis of vitamins and nutrients, regulation of the immune system, and defense against potential pathogens. In healthy persons, this balanced ecosystem is characterized by microbial diversity, including a complex community of bacteria, viruses, and fungi. The best studied of these microbes are the bacteria, which are subdivided into various categories, starting with the broadest division of a phylum. Although more than 50 bacterial phyla have been identified to date, 2 dominate in the healthy gut microbiome: the firmicutes, gram-positive bacteria, including spore formers, and the Bacteroidetes, mainly gram-negative anaerobes. In the healthy state, a diverse and abundant microbiome excludes potential pathogens by competing for available nutrients and an ecologic niche, a property called colonization resistance. However, the microbial diversity of the gut microbiome can be markedly reduced by the administration of antibiotics, leading to an ecologic imbalance called dysbiosis. Although antibiotics are life-saving when a pathogen threatens the life of the host, antibiotics can also kill the beneficial bacteria that promote colonization resistance. Dysbiosis can be short-lived if the microbiome is resilient. However, if dysbiosis persists and the patient is exposed to the spores of C. difficile, these spores can germinate into vegetative forms that produce toxin and disease. Thus, C. difficile infection requires 2 hits: exposure to the spores and a dysbiotic microbiome, which makes the patient vulnerable to infection. This 2-phase life cycle of C. difficile adds complexity to medical management. Patients do clinically respond to C. difficile-directed antibiotics, which kill the vegetative forms. However, if dysbiosis persists, patients are at risk for clinical relapse, since antibiotics do not inhibit the dormant spores, which can germinate and regrow once treatment is discontinued. The risk of relapse increases with every episode of infection, up to 60% in those with 2 or more recurrences. Furthermore, antibiotics exacerbate the underlying dysbiosis, which leaves the patient vulnerable to relapse or reinfection by another strain. Thus, the current paradigm of treatment with antibiotics alone is only half of the solution, since antibiotics do not address the underlying dysbiosis, which supports a vicious cycle of spore germination, toxin production, and clinical relapse. A new treatment paradigm, which addresses the underlying dysbiosis, is urgently needed.